So I've recommended to you that you use the interface builder for dealing with constraints all this time. But there are some cases where constraints in code are just necessary. There's just no way around it. So you might encounter some cases where you need to create and manipulate constraints directly in code. In this case, there are much less tools involved, and also we've covered the behavior of constraints in the interface builder part of the exercise, so this part will most likely end up smaller than the interface builder part. However, there are some additional things you need to know about. Here's what I'll focus your attention on. First off, we will take a look at the required objects and the required functions for creating constraints in code. And after that, we'll take a look at how to adjust constraints. We'll focus first on how to create constraints in code. Just like with the constraints we dealt with in the interface builder, there are a couple of things that need to be set in order for the constraints to work properly. The concept is exactly the same, so a valid set of constraints defines the size of the view as well as the position of the view. So just like the rules we had before in the interface builder. We need to set the width, height, and the x and y position of the view. So we need to create some variables that contain our constraints. The types of constraints may vary from situation to situation, but let's just say we want to replicate this login form that we had by creating the constraints in code this time. So a little bit of work is needed to set up the testing environment in this case. Let's just remove all our constraints we added in the interface builder and remove all the outlets for the constraints. We're now at a starting point where everything should be like we just pulled out the view of the object library and put it on the canvas. Now, we need to create an outlet for the view from the storyboard to the code file. Of course, you could also create the view inside of code and ignore the interface builder completely, but I'll focus on that in another module since there is a lot to cover here too. So the first object that is required to create a constraint in code is a view. Let's just refer to this as the logo view in this case, because this is the view that holds our logo of the app. The second object that we need is the super view, meaning the other view that our logo view is nested inside. This is necessary because Swift needs to know the two objects that the constraints exist between. In our case, this is just necessary for the position because the size will be just like we had it before, the 128 points by 128 points. We don't need another view for that. But the super view is necessary so we can define the position properly. The thing is, you can never connect a constraint to nothing. It always needs a first and a second object to work with. Now, in our width and height example, this is one of the special cases where the second object is not interesting for us, but I'll cover that later. You'll just see it in code. Just know that there are some exceptions to this rule. The last object we need is the constraint itself. Constraints are handled as Anna's layout constraint objects, which are part of the UI kit. You can just create variables of that type and save constraints inside of there. What's more interesting though is the constructor you'll need. I'll classify this as a function since a constructor is basically a function call that initializes the state of the object. Now there are just two versions for the Anna's layout constraint. The first one is an empty constructor call and it creates an empty constraint which basically does nothing. The other one is the interesting one. Let's look at the required arguments for this constructor call. First up, we have an item. Then we have an attribute, we have a related by, then we have a toItem, another attribute, and all of this is followed by the multiplier as well as the constant. Now, if you paid attention in the theory part, you might notice something right here. The graphic that I showed you that specified the anatomy of a constraint basically has exactly the same structure than the arguments in this constructor call have. Now this makes it quite easy to understand what is happening here, and this is the reason I taught you the anatomy of a constraint first. Firstly, we select an item. This is the object that should be aligned or adjusted based on the constraint. The attribute specifies which value needs to be set. Remember, this could be position or size related or even both. Then there's the relation. Most of the time you'll be looking at equals, but for example, if you want something to expand only to a certain width, you could use a more or equal / less or equal relation. Then there is the to item, which is the item the value will be taken from, and the attribute, which acts just like the attribute on the first item. Lastly, we have the multiplier and then the constant. Both of them should be familiar to you from the interface builder screen. Now you might have noticed that there are some cases in which you don't need all the parameters in this function, especially when setting the width or the height of a view. You don't need to have a super view because it just affects this one view, but the arguments in the function are required, so what can we do? Now Apple has a clever way of dealing with this. If you're familiar with optionals in Swift, you might know where this is going. Let's just say we want to set the height of a view with the name of view. We would enter view as the item and height as a parameter. In our case, let's just say we use the equals relation. So as you can see, first item is the view, the attribute is the height. Now this is where it gets interesting. You might be asking, what about the to item and the attribute of the to item? And that's really easy. As our to item, we just set nil. Now the interesting part is the attribute. This is where we will enter dot not an attribute. This is a case of an enum that is defined as 0, meaning this will not affect our layout equation in any way. We can now use the constant to set the height of a view. Sounds a little bit weird at first, but that's just something you need to keep in mind to work with. So you now know all the attributes, items, equations, and everything in between. But how do we tell this to the auto layout system? This is hard to explain using slides, so we're just going to jump right into Xcode to get this working. So let's just use this example again. I'm just gonna hide all the views right here because we are just going to focus on the logo for now. And I've cleared this whole project. We have the super view right here that I put in at the beginning for demonstration purposes, so I'm just gonna leave that in. And then we also have all of our REST views. Now we're just going to focus on the logo, and that's why I have hidden all the other stuff. Our view still has the constraints that it does match with the view controller. But that's the only constraints that I have in the project right now. The logo is completely free of constraints, and I cleared those by selecting the view and then set clear constraints on the selected views. Now, as you can see, this doesn't adapt anymore, but I want to have it adapt again because obviously we need that for our app to look beautiful. So what we're going to do is we are going to connect this object, this view right here. We're going to connect this to our code file so we can create the constraints inside of our code file. Now I'm just going to do that by control and click dragging inside of here. Let's give it a name, logo view, and connected. Now I have a function create constraints right here, and we also have a function call of this function right here that is inside the view did load. That means if our app gets loaded, the constraints get created and our view basically can adapt to screen size changes, rotations, all that good stuff. Now let's just start by defining the width and the height of this view. For that we need to create two variables, or in this case we can also use constants. Let's give it a name, width of logo view, and type ns layout constraint. Now, as you can see right here, we have both of the constructor calls that I told you about in the slides. The first one is empty, and then the other one has all the elements that we want. I'm just gonna align that so we can see what's going on. And actually, I'm just going to go into the code file so we can see what's going on. So the first thing we need is our view that we want to apply this to, and that should be the logo view. Then we have an NS layout attribute. we want the width, as we said right here, to be set to something. Now we would need to select the NSLayout attribute width. Now to do this, we could say NSLayout attribute, hit enter and say dot, and then say width. That works, but there's actually a shorter version in, I guess, Swift 3. It doesn't work in earlier Swift versions, but you can just say dot, and it also it knows that it should be of the NSLayout attribute, and then it suggests us all the options that we have. Now we could say just dot width, and it would also work. Then we have an NSLayout relation. We want this to be equal to a constant. And that is basically the same as above. We can say dot, and then we can say equal, greater than or equal, less than or equal. And we're going to use the equal as a to item. We just have this special case that we want to set the width, and we don't need a super view on which this constraint needs to apply as well. So we can just say nil in here because it is of an optional type. And as the attribute, we will say not an attribute. Then we have the multiplier, which should be 1.0. You can't set this to 0, otherwise you would multiply your value with 0, and obviously something times 0 is 0. So this always has to be 1.0 if you want the effect to see. This is a common mistake I see. And then also we have the constant. Let's just set this to 228, just like the constant we used before. Just gonna copy that because we're gonna do exactly the same thing for our height. And we're gonna give it another name. Height of logo view, and that should do it for this. Now, what else do we need? Let's jump back to the storyboard. We also did center it in the X and in the Y position and offset it to the top. Now let's just start by centering the whole thing, and we can adjust the constant later. Let center X position. Also, we would need the NSLayout constraint. Again, the same constructor. Just gonna copy that from above because it is nicely formatted. As an attribute, we will select the center X. We will set this to equal, and now the interesting part. We can firstly set the constant to 0 and the multiplier to 1.0. That's okay. But this right here is what we need to take care of. We now need another view. We need the view. This image view is nested inside, and that is this one. That is our view right here. So we need to connect this to code as well. Control, click, drag, and let's just call it super view. Connect. Format it nicely. Jump back into the code file, and now we can use the super view inside of here. And as an attribute, we are also going to use the center X. So what we're doing is we are telling the constraint that it should take the center in X position, which is here, and align it with the center of the super view, which is here. In our case right here, this matches up, but for example, if the logo was pushed off to this side, it would now see, okay, this is the center in X position on the logo view. This is the center on the super view, and it will align those both. Just like that. This would not work, for example, if I would set a constant. If I, for example, I set the constant to 20, it would take this, align those, and then push it off to the side by 20 points. Just like that. So that's what we're wanting to do. That is exactly why we use the logo view, the center in X direction of the logo view. We use the equal, we use the super view, and then we say center X again. What this does is it creates the NSLayout constraint that centers this whole thing in the X position. And let's do exactly the same thing for the Y position. We also would need the logo view. We need the center in Y position. Again, the super view and also the center in Y position right here. Last thing we want to do is we want to select super view dot add constraints, which is a function that you can call on any view. Now we have the first one, which is add constraint, and then we have add constraints. So one is singular and one is plural. We want to use the plural one because we have 4 constraints that we want to add. We would do this as an array, and we can basically do this by using the square brackets, then say width of logo view, height of logo view, center X position, and center Y position. As you can see, all the arrows right here will be dismissed because we are now using our constants, because Xcode was suggesting that we get rid of those because we don't use them, but now we use all of them. So let's just see if this works. So as you can see, it doesn't work. The logo isn't centered. And that is because I forgot something important. So let's jump back into Xcode and I'm going to show you what the problem is. The reason this whole thing is not working is because we forgot something important, and that is we forgot to tell our logo view that it shouldn't translate the auto-resizing masks into constraints. It shouldn't do that. And that is, you can disable that really simple by typing your view.translate auto-resizing masks into constraints and then setting this boolean to false. Whoops, false. And when we run it now, it should work just as we expected. And as you can see, it works just fine. When we rotate the device, the whole thing rotates with it, and the logo stays centered. Now let's offset this logo to here so we can start adding the buttons and the text labels. To offset the logo, we just want to find our constraint, which is the center Y constraint, and change the constant to, let's say, 140, minus 140, because we want to push it upwards. If you remember correctly, the iPhone canvas is arranged that the 0.00 is in the top left corner. So that means if we center it in the Y direction, we have to take minus to push it to the top. And if we would change this to plus, we would push the logo to the bottom. So that's why we want to use a negative value right here. Let's see if this works. So as you can see, it works. The logo is offset to the top. Now if you rotate it, it gets pushed off the screen a little bit right here, but we're not going to take care of that right now. Let's just focus on finishing this layout. So to work with our buttons, we first have to show them again. For that, we are going to push the logo off to the top a bit, just like our constraints would, and then we have to show all of the elements that I've hidden. You can do that by selecting them here in the side view, and then checking the installed checkbox right here, which makes them appear again. What we now need to do is connect all of those views to the code file and then apply constraints to that. So let's just go ahead and do that. Open up the side-by-side editor, and let's first connect all of the views. Okay, so with all of those connected, we now need to jump back into our code file first, and then we need to figure out which constraints we need, and then we can add them. So with all those views connected to the code file, we now need to create the constraints that we need for all of those views. Now that's going to be a little bit code heavy, so I'm going to fast forward that, and then I'm going to explain what I did there. So the first thing that I did was I created all of the width constraints that I want to apply to all the views. And basically what I did is I created the same NS layout constraint every time. The width with setting the width, setting it equal to a constant. I did not change the constant. The only thing that changed in all of those cases was the first item that the constraint would be applied to. Now, we need to create multiple of those because we can't change them. My go-to option would be to create a variable and then change the first item every time, but that doesn't work because the first item is a get-only property of the NS layout constraint. So we have to go this route. All of this is just to set the width of all the different views. So what I'm now going to do is I'm going to set all of the top constraints of all of our views that we have right here to make them dependent on the logo, just like we had it in the interface builder. Now I'm going to speed up the process again. I will just run through the code, write everything out, and then I'm going to explain what I did. So what I did right here is I created all the Y positions for all of our views. Now to explain this, I'm gonna just jump right into the storyboard again. And what I basically did is I chained them all together based on the logo so that we could have the same behavior as before, where if we would move the logo up, everything of our view right here would move up, all of our elements would move up as well. And I did that by chaining them together. I took the username top edge and bound it to the bottom edge of the logo view. Then I did exactly the same with the text view. So the text view top to the username bottom edge with a constant of 0. And here I applied a constant of 30 so that we have a little bit of space in here. Then again, I used the password top edge and bound it to the bottom edge of the username text box with a constant of 30. Then again, the text box of the password with 0, same thing again here, and then the same with the login top edge to the bottom edge of the text field right here with a constant of 30. You can see that right here. I used the username label and bound it to the logo view bottom. So username label top to logo view dot bottom. Username label top to logo view bottom. And I applied the constant of 30 right here. And then I basically did it for all the different views. So now our Y positions are set. What we now need to do is we need to create the X coordinate for all of our views, which basically means we would need all of them to center into the X position, which we did with the logo view as well. And then we're basically done. So let's just go ahead and make that happen. We can do this again by going into the code file, you know the deal. And what I'm going to do is I'm going to take the center X position, copy it, and append it to the bottom. I'm just going to fast forward through this and I'm going to explain just like we did the times before. So again, what I did, I took all the elements that we needed, all of our views, took the center in X direction and set it to equal to the super view center in X direction. Exactly the same as we did it on the logo view, so nothing too fancy right here. Now there are a couple of things that we need to do, and then we're done. First off, we had this line right here, remember? It didn't work properly in the beginning. That's what we're going to do for all of our other views as well, because they are also trying to translate our auto-resizing masks into constraints, which is not a good thing for us. So we're going to copy this and append it to the bottom. So, and now that we've done that, all there is left is we need to add all of our constraints to the super view. And now we should be done, if I haven't forgotten something. We created all the constraints that we need. The height constraints we didn't need to set in this case because they are inherently set on all the views that we needed. We have set the width right here. We have set the Y position based on the other elements that are in the view, so we chained them together. And then we also centered it in the X position. Also, we have turned off the translation from auto-resizing masks into constraints for all of the views, and we have added all the constraints to our super view. So let's give it a shot and see what it looks like. And there we go. This is what our view looks like. So this is 30, this is 0, this is 30, this is 0, this is 30. And it all looks pretty nice. Let's just see what happens if we rotate the device. And as you can see, everything adapts. Now, as we had it before, the logo still is pushed offside of the canvas, but like I said, we're not going to take care of that right now. This is stuff for another module, since there is a lot to cover there too. But all of our constraints are working nicely. So as you can see, it's not that super straightforward to create constraints in code, because it's very, very much that you need to do. You need to set a lot of constraints. This is a lot of code that we have created in this short time, and basically it's just repeating stuff. It's not very interesting to write. But for example, if you're dealing with Git and you have to resolve merge conflicts, for example, this is much easier to maintain than, for example, if you would have added everything inside of the storyboard right here. So it makes dealing with constraints a bit easier if you're working with teams, but if you're working on small projects, you can easily just take the route and go through the interface builder, which is anyway something I recommend when you're just starting out, because just like I said, the visual representation is just it's just gold for understanding what's going on in there. If all of this wasn't enough for you, if you want to see more about how to apply constraints and different types of constraints, different permutations, there are some examples in this module in the extended access, where I have some other examples apart from this one right here that we've been using the whole time, where I go into a little bit more detail about what you also can do with constraints and how you can use those. Greater or equal, as well as less than or equal constraints relations, and many more things. Also, where we have some on macOS, where we create an application on macOS using the constraints, but it's basically exactly the same like for iOS that we did just right here. So now that that's done, let's just go ahead and jump into the last two lessons of this module, and you're ready to go.